I welcome you all to the day 9 lab session. So in this class, we are going to see how to interface the sensors. In that, only two sensors we are going to see. One is the temperature sensor, another one is the PIR. Okay, first we will see the temperature sensor. Before that, I will show a few sensors available in our Tinkercad. Potentiometer, whether potentiometer is a sensor or not. Yes, it is a simple sensor. Using this sensor, you can find the angular motion. Many of the physical quantities you can measure with the help of simple potentiometer. Then we have a temperature sensor, then PIR sensor, then light sensors, LDR, photodiode, phototransistor, then tilt sensor, then gas sensor. At last, we have a ultrasonic sensor. These are all the sensors limited in our Tinkercad software. Okay. Today's class, we are going to see only these two sensors, this temperature and PIR. So what are the exercises we are going to do? The first exercise, we are going to interface the TMP36 sensor with the Arduino and display the temperature value in the serial monitor. This is the first task, what we are going to do today. The second one, with the help of PIR sensor, we are going to detect the motion. Okay. So as sir told already, this is the characteristics of our temperature sensor. Here, this is the B curve is related to our TMP36. So since it is a linear curve, so simply I can use the map function and I can read the temperature value from the sensor. Please make note of few readings. Let me compare with our result. As per the data sheet they given, at 25 degrees Celsius, we will get 0.75 volt. Please make a note of these few readings. These are all given in the data sheet. So at 25 degrees Celsius, my output voltage is 750 millivolt or 0.75 volt. This is the data given in the data sheet. And from this graph, it is clear that at 50 degrees Celsius, my output voltage is 1 volt. Once we done the interfacing, we will check these two things. Okay. At 25 degrees Celsius, what is the voltage we are getting? At 50 degrees Celsius, what is the value we are getting? These two are, we will take it as a cross check points. Okay. Now we will enter into the interfacing diagram. As sir told already, the range of the temperature sensor is minus 40 degrees Celsius to 125 degrees Celsius. Minus 40 degrees Celsius to plus 125 degrees Celsius, the range of the temperature sensor. So how to interface? It's a very simple connection. Please make a note of it. This is your temperature sensor. You have a 3 terminals. The left hand side first terminal is the power pin. There we are going to give the 5 volt input supply. Then the last terminal, third terminal, is the ground terminal. There we are going to connect our negative potential. Then the middle point is our output voltage. From that output voltage point, we are going to read the analog output from your sensor. At the same time, I'm going to measuring with my multimeter. Okay, so the name of the temperature sensor is TMP36. Okay. Just observe the video, what we are going to do today. Please observe 1 minute. Immediately we will get into the exercise. So minimum range minus 40 degree and maximum range is 125 degrees Celsius. So this is our program part. What we are going to type it in our program session. Okay. So we are going to read the analog sensor value and we are going to map with that. Then we will going to display it. Okay. There are two ways to map. Sir explained you how to read the value, then how to convert it step by step. Here, if you have a multimeter, you can note down the range of voltages. Okay, see here, please observe, if I keep my sensor in minimum temperature value, that is minus 40 degrees Celsius, this is my analog output voltage. Okay, this is my analog output voltage. Now I am going to increase the temperature to the maximum temperature. This is my 1.75 volt. If I know these two ranges, this is only possible if you are having any simulation tool like this, then only it is possible to do the mapping immediately, or else step by step you need to feed the value and you have to scaling your values. So I will show you the simplest method. If you have this kind of simulation tools, we can observe the entire range of the temperature as well as the analog output voltage. By the analog output voltage, if you exactly map, immediately we will get the Celsius output. Okay, so likewise we are going to change the temperature range and we are going to observe the output. Okay, now you come to the simulation portion. Open Tinkercad. So I took a previous exercise diagram. Let me erase the. Sir, is it visible, sir?
Yes, sir, it
Okay.
is visible.
Can anyone type what is the number of the temperature sensor or name of the temperature sensor? What is the number of the temperature sensor you have? Where we can fetch the temperature sensor? So go to this menu, select all, come down, in the input section. Please observe, in the input section, simple push button, potentiometer, slide switch. After that, whatever the components you are viewing is an sensors. So in that I need to pick my temperature sensor. See, this is my temperature sensor, TMP36. Select the temperature sensor or keep it in the breadboard. So what are all the pin terminals? Please observe. This is power terminal. This is V out. This is my ground. Then along with that, we'll take a multimeter to measure the output voltages. To measure output voltage, see, this is my multimeter. I fetched this multimeter. So I'm going to measure only the voltage. By default, it will show only voltage. So I keep it as a voltage. That's all. Now we need to wire the sensor. So this is power pin. Power pin need to be connected in plus 5 volt. Power pin we need to connect it in plus 5 volt. Plus 5 volt. Okay. Then this is my ground pin. Ground pin I need to connect it in ground terminal. Then any one analog input pin we can use. We are going to use A5 in this case. That's all. So sensor wiring is finished. Please observe, we have only three terminals. First one is power. We have connected to VCC. Then the last pin is ground. We have connected to the ground terminal. Then the output terminal is connected to the analog input pin of our Arduino board. Then along with that, I am going to take multimeter. Keep the multimeter. See. So always the ground terminal. With respect to ground, we need to measure the voltage. So what I'm going to do, I'm going to connect this negative terminal here. So negative terminal I have connected with the ground terminal. Where I need to connect this positive terminal of the multimeter, can anyone tell? Positive terminal. Shall I connect it here? Where I can connect this another end of the multimeter. I need to check the output voltage correspond to the temperature. That means I need to connect it in the V out terminal of the sensor. Please make a note of it. V out terminal of my sensor. Okay, that's all. Please observe the diagram. I have connected the temperature sensor and I have powered it. Then output terminal I have connected to the analog input pin. At the same time, I am going to measure the output voltage also. For that, I am going to use one multimeter. Now we are going to write the program. So let me erase the previous codings. Whatever thing related to our today's exercise, we will include. So here we are not going to use any display unit. Here we are going to use our serial monitor as a display unit. Okay. For that, what are all things can anyone help me? Pin mode. In pin mode configuration, what I have to do? Can anyone type it in chat box? Pin mode. Pin mode. Pin mode ledu type panano. Can anyone type it in chat box? Which pin we need to use? Hello? A0, okay. Anthony Surya, please observe the circuit diagram and tell. Please observe the circuit diagram. Which pin we have used? Which pin we have? Very good. A5. So A5 pin number A5 input. A5 input. That's all. So over. Then how to initialize the serial monitor? Can anyone type the syntax in the chat box? Serial dot begin of 9600. Very good. Serial. That's all. So since I want to observe the output in the serial monitor, I'm going to initialize the serial monitor. Okay. So now I need to declare the one variable. Then I need to read our temperature sensor value. Okay. For that, let me declare one variable name called. Simply, I'm going to give the variable name as TM36 sensor output. Okay, TM output. TM36 sensor output. So sensor output என்ன analog value வருதுன்றதை இப்ப நம்ம read பண்ணணும். Read பண்றதுக்கு என்ன syntax யூஸ் பண்ணணும்? Analog read off. What is the pin number I need to mention? A5. Very good. A5. That's all. Then what we will do? We will print the analog value corresponding to the temperature range. Once we got the range, immediately we will do our remaining portion. Okay, so step by step I am doing. So if you have a simulation tool like this, then only this step is possible. Okay, serial dot begin. I'm going to change it as serial println. Simply I'm going to type the temperature sensor variable value. Okay, then give some delay. Let me give 1 second to view my reading. That's all. Please observe step by step only I'm going. I'm not going to execute the full program. See, now just I am going to read the analog sensor output value for the entire range of my temperature sensor. Okay, so I'm going to start simulate and I'm going to open my serial monitor parallelly. See, please observe the multimeter reading first, then we will come to this code portion. See, come here. First observe my multimeter reading. As per the data sheet, whether I am getting the output voltage, we will check it. The checkpoint, as already told you, at 25 degrees Celsius, I should get 0.75 volt. At 50 degrees Celsius, I should get 1 volt. These two things we will check first. Okay. Now I am going to change the temperature value. How I can change the temperature value? Just click over the temperature sensor. See, by default, they gave 25 degrees Celsius. Please observe your data sheet diagram. This is the default value given in the data sheet. It's the same thing with they also simulated. See, by default, wait a minute. See, by default, 25 degrees Celsius, 750 millivolt is the standard value they given in the data sheet. In simulation also, once you start simulate it, it shows only that reading. See, please observe. At 25 degrees Celsius, I am getting 749 millivolt. There is a plus or minus 1 millivolt error is there. Okay, we will leave that one. Then I am going to change the temperature to 1 degree. What is the second reading we need to observe? At 50 degrees Celsius, we will check. At 50 degrees Celsius, as per the graph, I need to get 1 volt. Please observe. Please observe here. Exactly, we will get 1 volt as an output. I'm unable to keep it in 50 volt. Okay, I will keep yes. See, 50 degrees Celsius, it is nothing but 999 millivolt. That is nothing but approximately 1 volt we are getting. Is it clear? So as per the data sheet, we are getting the readings. So no issue on that. So if I keep minus 40 degrees Celsius, this is my analog output value. If I keep the temperature sensor into the maximum value, this is my 1.75 volt. What we are going to do with these two extreme values? Very simple. Come back here, open the code window, observe the serial monitor reading. Now I am going to keep the temperature value as a minus 40 degrees Celsius. Please make a note of our serial monitor output. It is the equivalent count for the particular voltage is 20. The equivalent count is 20. What is the maximum count I am getting? See, I am going to increase the temperature sensor value. I'm going to keep it into the maximum value of 125 degrees Celsius. 125 degrees Celsius. This is my count. What is the maximum count? 358. Please make a note of these two counts. For minus 40 degrees Celsius, the count is 20. For 125 degrees Celsius, the count is 358. Now I am going to use these two values, and within the single step, we are going to get the output. Wait, I'm going to stop the simulation. Again, I am come back to our program. See, I'm going to use the map function. If I don't have the simulation software, whatever the SAR told, the same step we need to follow. I need to convert first scale factor, then I have to multiply with some multiplication values, then I need to produce the output. Now I am going to simply create the another variable name called temperature. That is equal to map of, this is our analog sensor output value. Simply copy this variable name. From value and to value, analog value I need to tell. What is the from value? From value, the count is 20. What is the to value? Can anyone tell? What is the to value? For 125 degrees Celsius, I am getting 358. So simply you type it over 358. That's all. These two are the analog values we are reading from the sensors. These are all two extreme from and to values of my analog. These values I need to scale it to again two values. What are all the temperature from value and to value? Temperature from value is minus 40 degrees Celsius. What is the maximum value? 125 degrees Celsius. That's all. If you have a simulation tool like this, simply you can complete the exercise in a single step. Okay. Now I am going to print my temperature value in the screen. Okay. So temperature value I am going to simply print. So for that, let me change the variable name instead of temp output into this temperature value, and we will see the output. So this is my serial monitor. And come back here. Yes. Now I am going to don't think. Yes. Please observe. Please observe. What is the minimum value, maximum value I'm going to set? Wait a minute. I'm going to. Yes. We keep it here. Yes. Now you observe. I'm going to change the temperature value. I'm going to change the temperature value. See, now I'm keeping extreme end. What is the temperature value you are getting? See, minus 40 degrees Celsius. Minus 40 degrees Celsius. Maximum value I'm going to adjust now. Maximum value. See, 125 degrees Celsius. So if you have a simulation tool like this, you can take the minimum value and maximum value, equivalent analog output value, you can check it in your serial monitor. Then what is the output you need to print? That scaling factor, you know, that is minus 40 degrees Celsius to 125 degrees Celsius. So within the single step, I can map these two things. So this is the count equivalent to 20. So the whatever the formulas are given, if you calculate for minus 40 degrees Celsius, you will get the count as 20. For 125 degrees Celsius, I will get the count as 358 degree. Sorry, for 358 is the equivalent count for 125 degrees Celsius. In this way, we can make the temperature to print in the monitor. Okay. So if I simply print the values in the monitor, it will go give only this kind of reading. If you want to add some strings before and after, I will tell you how to add those things. Listen. So here, before typing the temperature value, I'm going to label the value. So simply, I'm going to label it as temperature. Within the double quote, I'm going to type temperature value is equal to this variable name TEP temp. So this temp is nothing but the equivalent temperature value what we have calculated with the help of this map function. After that, I need to include the units. Okay, degrees Celsius. How we can print the degree Celsius? See, simply if I use the same string value in the string pattern, I can simply type instead of temp. If I type it as capital C, if I type it as a capital C, you will get the output. See, temperature is equal to 24C. Can you view this? So how to add the degree before that? How to add the degree symbol? So here we don't have any symbol in between 24 and C. So how to add symbol, the degree Celsius means the degree symbol I'm going to use on special code. Those code and all you will study later. At this point of time, you make a note of this syntax alone. So once you study digital electronics, you will type different type of coding technique. So here I'm going to add one character. Here I'm going to add one character with the number. So different characters have a different number. So here we are going to type character. So far, if you have any doubt, please type it in chat box. So the character 176 is the equivalent value of your degree symbol. These things you will study later. What are the different types of decoding techniques available? This is
they would have studied C programming. They would have studied ASCII, Kajendran.
Sir, actually, sir, in the 176 ASCII kila varling sir, the UT36 no something.
UTA format la okay.
UTF coding la irukku. If you refer UTF 8 byte decoding la 176 is equivalent to your degree symbol. Okay, so now I am going to start simulate, check the output. That's all.
Yes,
Sir,
sir.
சொல்லுங்க sir.
For LCD, it may differ.
LCD. For LCD, you have a different ASCII values. We will circulate that one. So in a real project, you can't give the CPU to your customer. At the time, you will use LCD or some other display unit. For that time, we will give you the ASCII key, read the ASCII key and type it. Is it okay? Now I'm going to change the temperature minus 40 degree. Yes, it is a minimum temperature. I'm going to increase the value into 125. It's 125 degrees Celsius. If I want to keep it in 0 degrees Celsius. 0. Okay. If you maximize, you can do it, but in the label வந்து hide ஆகுது நம்ம temperature sensor. Okay va? If you don't have a serial monitor means you can view those things clearly. See, if I hide the code window, then you can check the entire temperature range what I am adjusting in the display. See, now you can view entire temperature range. I can vary from minus 40 degrees Celsius to 125 degrees Celsius. I can keep it in exactly 0. See, I'm keeping it 0. Then we will open code window and check. So, okay, 0 degrees Celsius. In this way, you can program this. You try both the things. Whatever are shown, that also you try. Both the program you could make practice and get the same output. Okay. So that is step-by-step calculation. That also you can do it. Then one more thing, how to convert. So here I have shown only degrees Celsius. How to convert it into Fahrenheit? How to convert into Fahrenheit? Very simple. This is the variable. This is the variable equivalent to degrees Celsius. So if I want to print the value in the Fahrenheit means, so here I kept the value as an integer. Therefore, I am not getting any values in between the whole values. If you want to check it in the fraction value, you change the variable name into float. Okay. So change the variable name into float. Then change the variable name into float. Then I will show you how to convert it into Fahrenheit, how to convert into Kelvin. You try it by your own. Okay, it's a simple mathematical formula you need to apply. So here I am going to convert this temperature into Fahrenheit. Temperature into Fahrenheit. Okay, so how to convert into Fahrenheit? I will show you. Kelvin, you try it by your own. Okay, so I'm going to convert into Fahrenheit. So this is degree Celsius. By default, my sensor will give only what? Degree Celsius value. Now I need to convert into Fahrenheit. How I convert? How I can convert? So I need to multiply my degree Celsius value. Multiply my degree Celsius value with 9 divided by 5. 9 divided by 5. 9 divided by 5. Then the whole term I need to add with plus 32. I need to add with 32. If I do this simple conversion, my degree Celsius value, I can convert it into Fahrenheit. Okay, these are all simple mathematical formula. Okay, so then what else? That's all. Now I am going to print the Kelvin, Fahrenheit values also in the serial monitors. Okay, so let me follow the same thing once again. See, I'm going to print the variable called temperature in Fahrenheit. Temperature in Fahrenheit equal to, okay, equal to. Then what is the variable I need to print? Simply temperature Fahrenheit. Then I'm going to type it capital F. Please go through these statements alone. This is first one, temperature in Fahrenheit. This is the formula. This is we have studied in basic physics. So how to convert degree Celsius into Fahrenheit. Then these are all very simple things how I can print. Here I will add one more thing. This is the first statement. This is the first statement we are going to view. If you want to print the other statement, in between if you want to add some tab means, please make a note of it. This is a syntax to make the tab in your serial monitor. This is the first word. Second, I'm going to print this. In between, if I want to produce some space means, this is the tab character. So /t will make the one tab space between these two values. Then I can view the output in a comfort manner. Okay, shall we check the output now? See, you know that minus 40 degrees Celsius as minus, see, at the only for minus 40 degrees Celsius, the Fahrenheit reading and Celsius reading will be same. If you want to cross check whatever the formula you have given, we will keep our temperature sensor in minus 40 degrees Celsius, then we will check our output. Okay, now I'm going to start simulate this. Please check the output. Somewhere we did the mistake. Okay. See, in between temperature value in degrees Celsius and Fahrenheit, I introduced on tab. For better visual output, I have made it like that one. So now I am going to change the temperature value. Now I am going to change the temperature value. See, let me keep it in minus 40 degrees Celsius and check the output. Oh, Fahrenheit. Mistake இருக்கு. Wait பண்ணுங்க. 9. We'll check once. Degrees Celsius. Fine.
Yes, sir.
Sir.
Into 9 divided by 4 போட்டு பாருங்க. Bracketல.
Okay.
9 by 5 போடாம into 9 first பண்ணிட்டு அப்புறம் divided by 5.
Into 9, the whole term into 9, then divided by 5, then whole term plus 5. Let me check it. Temperature value, let me change it to 40 degrees Celsius. Yes. Yes, now you check it works. Okay. So at minus 40 degrees Celsius, my Fahrenheit value as well as degree Celsius reading will be same. Please observe. Please observe. I'm going to keep it in minus 40 degree. Now you check the output. Is it okay? Is it okay? That's all. In this way, you can create one digital thermometer. We will give you one task at the end of the class. Okay. So far, if you have any doubt, please ask us. Two things we have learned new today. One is how to read the one analog output value, then accordingly how to map it. So these are all the range. It is no longer 0 and 1023 all the time. According to our practical input value, what it is the meaning means, this is the minimum value of the analog read I am going to receive it. This is the maximum value of the analog value I need to read it. And I am going to map it with the required from value and required output value. This is the one thing. Then the second thing, how to make the conversion factors. These are all simple mathematical calculation. After that, how to print on character. See, here I will do one thing. If I remove this character and start print, please observe. If I remove the character symbol and start print the value, it will print only 176. Please observe here, it will print only 176. So within the argument, if you pass any numerical value in a decimal format, it will print only the decimal value. So if you want to get the particular character, means you need to include this function character. This kind of mistakes you will commit while you do the experiment. Okay, let me stop with this. Please make note of these readings. The demos, immediately will come to the simulation. See, from where we will fetch the PIR sensor. Again, you go to input. There you will find the PIR sensor. Pick the PIR sensor. As sir told already, first we will see the pin out. So this is signal, this is power, this is ground. If you compare with the previous temperature sensor, there is a slight modification in the pin configuration. Therefore, whenever you start do the experiment, please find the pin out. That is nothing but a pin is exposed to connected to the external hardware. That is called as a pin out. Okay. So the pin out terminal from the data sheet you can find, but here it is very simple. If you bring the cursor, it will give the pin numbers. But in a real
கடையில இருந்து
world,
அவங்க வாங்கினாலும் அவங்க வந்து அந்த
yes,
சென்சார்ல என்ன மார்க் பண்ணிருக்குன்னு பார்க்கணும்.
yes,
ஏன்னா கமர்ஷியலா வித்தியாசப்படுதுங்க.
yes, yes. Simulation software and the real hardware components have a little bit pin modifications. So buy the component, check the pin out, then only you need to connect. Okay. See, this is power signal, power and ground. So wherever you find power, typically it is a 5-volt power supply. Okay. So I'm going to bring the PIR sensor into our circuit board. Okay. So the first pin is the ground. So straight away connected into ground. Okay. The second pin is power pin, connected into 5-volt. Okay. Then this is a signal out. So it is only either object is present or not. Either motion is detected or not. True or false. That means digital output. So I am going to use only the digital pins. I am going to use it. Shall we use pin number 7? Yes. Digital pin number 7. I am going to use it. That's all. Then at the same time, I'm going to measure my multimeter output also. I'm going to connect it across the ground and signal output terminal. Okay. So one terminal I have straight away connected to the ground. Then the other terminal I'm going to connect it in the signal output terminal. This is our signal output terminal. That's all. Okay. If I without any program, if I start simulate it, okay. Okay, we will finish the program and simultaneously we'll run. Please help me. Where I have connected? I have connected in pin number 7. So pin number 7, I need to configure as an input mode. Okay. So pin number 7, input mode. Again, I'm going to check the output in serial monitor. Then I need to read the status of the variable. Okay. Here we are going to use the new data type called Boolean. Boolean means only 0 or 1. This is the one type of data type. So I'm going to use Boolean PIR. So all the digital sensors, you can use this name as a data type. Okay. So PIR sensor, I'm going to read only the digital pin. Therefore, digital read of, what is the pin number? This pin number 7. That's all. Then I'm going to check the PIR sensor value. What kind of modification I'm going to get? We will check it once. Then accordingly, we will write the program. See, I'm going to read the PIR sensor value. Then straight away, I'm going to print it. See, start simulation. Open code window. Open code window. and as well as open the serial monitor. I'm going to maximize the serial monitor. Please observe here, by default, my multimeter output voltage is 0. That means the signal, what you are receiving from the signal pin is 0 volt. If you observe the corresponding logical output, that is also 0. Now I am going to give the motion deduction. How I can give? See, always what you have to do, please click the sensor. Okay, while in the simulation mode running, while you while you run the simulation, at that time, if you click the sensor, you will get some appearance. Okay, so this is the object. This dark round is the object. Just I am going to move the object. See, logic level change to 5 volt for a moment of time. At the same time, you observe the output here. Only at that moment I got 1. Again, you observe both the multimeter reading as well as our serial monitor output. I'm going to clear the window. Initially, it shows 0 0. Now I am going to give one small motion. See, moment of time, it will produce logical output high. Okay, this change, based on this change, I'm going to produce my output. Again, I will show you once again. See, small. So this is the range. This light color is the range. Beyond, if I move the object, it won't produce any output. Okay, in between this, in between the range, at the same time, the all the axis, x-axis, y-axis, z-axis, all the thing have the range. Okay, if I move the object little bit, it will give logic 1 for moment of time. After some time, it will produce logic 0. I'm going to use this. How I'm going to use this in my program? See, here I'm going to print. Here I'm going to only print the serial statement. If a particular PIR sensor value, while sorry, if I detect the motion of the object, what is the logic level I received in my output? I received the logical level as 1. Either I can type it as 1 or high. Both has the same meaning. See, so far we have typed high. Now I am going to type simply 1. So it is also a logical value. If it is high, I need to type the statement as object detected. Okay, shall we type? A motion detected. Okay, detected. Else. So I'm going to give little delay to view the output. Else part, what I have to do? Else part, simply I can type any value. Here in else part, I'm going to type my project name. Okay, because most of the time this will be in the output mode. Only moment you detect the object only, we will get the output as object detected. So in the else part, I am going to type it as my project name. So example, I am going to type it as KCE PIR project. Okay, that's all. That's all.
Actually, when you do an application, motion detected, motion not detected can also be there.
Yes, sir. Motion not detected also can type. Okay.
It will be more relevant to the project.
சரி எல்ஸ்ல ஒரு சின்ன எரர் இருக்கு.
எல்ஸ்ல ஒரு டாட் இருக்கு நடுவுல.
Yes, sir. See, now you observe the output. By default, it gives my project name. Okay. As I told, you can type object is not detected. Okay. Now I'm going to move the object. See, motion detected. Motion detected. Okay. So using the same logical level, you can create any one digital input output as a high or low. You can make it. I think that portion you can do it. So I'm going to stop here. In this portion, in the logical high or low portion, you can include whatever the thing you can use it. So if you want to make any buzzer to give alert, or if you want to make any burglar alarm, like those kind of things, you will give an alarm to turn on and turn off. Okay, those things you are very much familiar. So with this, I'm going to show the today's task. Today's task. Please note down. So using using TMP36 temperature sensor, design and implement a digital thermometer. Okay, first task, digital thermometer. Obviously, you are not going to supply the CPU and all. Use some display unit. You know which display unit you can access. Try that one. The second one, using PIR sensor, design and implement a non-contact digital calling bell with a door lock security system. The second point so far we didn't taught. You try yourself how to make the security system by your own. Calling bell you can make it. Okay, this portion try it by your own. How to create a security system, simple security system, you make it in your point of view.